Projectile motion. A body thrown with some initial velocity. Initial velocity. Underline this, initial velocity. Then it is allowed to move under the action of gravity alone. So, action of gravity alone is called projectile. So, this is called projectile. So, what do you mean by projectile? Projectile is the body thrown with some initial velocity, point number 1. Then, it is allowed to move under the action of gravity alone, nothing else. Okay. So, there will be some initial driving force, and now it starts with the influence of what? Under the action, it is under the action of gravity. Okay. For example, a boy on the ground, he is throwing a ball. So if he throws the ball, it will go up and reach the maximum height, and then it should fall down on the ground. This is a projectile. Okay. And sometimes it will be the same boy can throw like this in order to cover the maximum distance. Okay. So now you can find that there will be a maximum range here. And the third is sometimes that is at the tip of a clip. Okay. Where we can, that is, throw a body. If it is thrown, it will fall on the ground like this. Let me say this is the ground. So these are all different types of projectiles. So in this case, the projectile, that is the body, is projected horizontally. Body projected horizontally from certain height. Got it? Sometimes it can be thrown from the ground also. In order to make a parabola, the path of a parabola. So we can say this is the horizontal projectile and this is the vertical projectile. Okay. So let us consider the motion like this. Motion. So when it is a horizontal, and when we talk about the force, so initially no force acts up. And the velocity will be constant. Then there is no acceleration. It means there is no change of velocity. When velocity is constant means what? There is no change in velocity. So it means acceleration is 0. And let us talk about the vertical motion. In the case of vertical motion, the force of gravity acts downward, is it not? The gravity will act downward. So the force of gravity, that is gravitational force, acts downward. Got it? Downwards. And normally it is 9.8 because there will be a change in velocity. Is it not? Roughly we can say 10 meter per second squared. And that is nothing but the gravitation, that is acceleration due to gravity constant. Is it not? 9.8 into 9.8 meter per second squared, or roughly you can say 10. And here also there is an acceleration, so it acts downward. Downward, it is 10 meter per second squared. Okay. Now let us consider this horizontal projectile. Shall we move? Draw the diagram. This is at certain height. The body is at certain height, h. And from this your body is thrown. It means it will have a horizontal velocity that is constant, u, and it will fall down like this, is it not, on the ground. Okay, so and touches the ground at B starting from A. So this is a curved path, and let us see at A the constant velocity, horizontal constant velocity, and at that point the initial velocity u1, that is the vertical velocity, is equal to 0 at that point. And when it reaches the ground, that is, it will be the maximum. And not only that, let me consider two positions, that is C, constant velocity u, there is no change in that, this is C. And what about this one, downward velocity under the influence of gravity, u2, because that changes. And at D the constant velocity, horizontal velocity, is constant, and the vertical velocity u3 is varying. Okay, and in fact from the foot of the that is a certain height, or let us say a hill, okay, from this place to this place we call it range, R. So what is R? R is equal to range. So that is the foot of the certain height and the distance where it falls. Okay, so the distance between the foot and the body falls and hits the ground. So that is R is equal to range. What about U? It is, these are all constant velocity, constant horizontal velocity. Initially the u1 was 0. The u1 was the u1, u2, u3, these are all what? Vertical velocities, downward, acting downward, vertical velocity. What about this vertical velocity? That is under the influence of acceleration due to gravity, is it not? So that keeps on changing. So at u1 it is 0, that is at A u1 is equal to 0, and it will be varying at B and C and D. Okay, you should know certain terms here. angle of projection. It is the angle between the initial direction of the projection. Initial direction of the projection and the horizontal direction. Horizontal direction. Through the point of projection. And you should know something about the velocity of projection. Velocity of projection. Velocity of projection is the velocity with which the body is projected. Okay, so the velocity with which the body is projected. Range. Range is the horizontal distance, that is this one. Horizontal distance between the point of projection and the point where the projectile hits the ground. Point where the projectile hits the ground. The path described by the projectile. For example, let me consider this. This is the projectile, and when it's thrown, it makes an angle, okay, that is theta, and it covers certain distance, that is the range, and the parabolic path, that is called trajectory, the path described by the projectile. So what is trajectory? Take down. Trajectory. So what do you mean by trajectory? It is the path described by the projectile. Now time of flight. It is the time of flight is nothing but the total time taken by the projectile from the initial point till it hits the ground. Okay. Shall I proceed? What's the point number? Last point?
7.
This is 7. 8, huh? 7. Okay. Now the time of flight. The total time taken by the projectile. From the instant of projection till it strikes the ground. Now let me draw the diagram. This is the x-axis, this is y-axis. Now I am throwing the projectile like this. It travels and it reaches the maximum height, and then it comes under the influence of the gravity and hits the ground. Okay, so its maximum height is at A, and it travels with some constant velocity, the driving velocity here, and that makes an angle, that is the angle of projection, as I have already discussed. I hope now you should be able to understand the theta, which is nothing but angle of projection. This is x-axis, this is y-axis. And then, so A, this is E, so this is the vertical height. Let us say this is the maximum height, H max. So what is H max? Maximum height. Maximum height of the projectile that it can reach. U is the initial velocity. And it starts from O, and meanwhile it can reach the position C, where you have got the horizontal velocity, that is Ux. So Ux is the horizontal velocity. And then it has got the vertical velocity U2. And here it is U3, where it reaches, for a moment the velocity becomes a 0, so U3 is equal to 0. Then after that the velocity, the vertical velocity changes its direction at D. So there will be Ux, it is constant horizontal velocity. As I already mentioned, the vertical velocity will be changing. So that is U4 here. What about this? This is U1. It has got some velocity U, which is nothing but U1, initial velocity. So there will be some initial velocity, and there will be a change of velocity, and there will be a zero at A, that vertical velocity. But in all these cases, horizontal velocity remains constant as ux. Do you understand this? The only thing is vertical velocity is going on changing. So we know that is the vector can be resolved into two components. One is vertical component, another is horizontal component. The horizontal component can be ux, here u along x, which is nothing but u cos theta. And what about this one? This is uy. Okay, so you can write this as uy. So that is equal to u sin theta. It means the u is the vector, the resultant vector u is resolved into two vectors. Okay, that is called resolution of vector. For example, when you have got a vector like u, and this is the y-axis, this is the x-axis. So let us call it, this is x, this is y. We want to resolve this vector, and it makes an angle theta with the horizontal. So let us draw a vertical line, and that is 90 degree, and this is theta. Let me say this is O, this is for instance in this case let us put A, and here E. Okay, now OAE, I am considering this right angle, this is right angle, is it not? So OEO, E is right angle, and you know very well this is U, that is the hypotenuse. And if it is theta, which is opposite side, AE is the opposite side. Do you agree with me? AE is the opposite side, which is nothing but UY, correct? And the adjacent side is UX, that is OE, right? Now what is sin theta? Sin theta is equal to opposite by hypotenuse. What is opposite here? This is AE, is it not? So AE divided by U, am I right? Which is nothing but OU, you can put simply U, which is nothing but AE is nothing but UY divided by U. Now we can have UY is equal to U sin theta. Okay. So here we have now UY is equal to U sin theta. Similarly, what is cos theta? So you know very well UY is equal to U sin theta, and that is why I put UY is equal to U sin theta. Then UX is equal to U cos theta. How? For example, what is cos theta here? Cos theta is equal to adjacent OE, which is nothing but UX divided by theta, that is U. Therefore UX is equal to what? U cos theta. Do you understand this? That is U cos theta. Okay, right. So we have these two important equations, that is representations. Okay. We have the vertical velocity and the horizontal velocity. The horizontal velocity, that is Ux. Okay, Ux, this is constant, that is horizontal velocity. Whereas vertical velocity, that is U1, U2, U3, these things, U1, U2, U3, etc. at various instances. This is variable. So variable vertical velocity. So we have now two types of velocity. Do you agree with me? Okay. So the vertical velocity is variable, and then in fact these two velocities are independent. Okay, So we were talking, let me consider this as two types of velocity, two independent velocities. Okay. So one is ux, another is this u1, u2, u3, etc. These are variable vertical and constant horizontal velocity. So do you understand this? And these two are independent of each other. Why this is variable? Because this is under the influence of what? Acceleration due to gravity, g, of earth. Next, the path of the projectile. Path of a projectile. Now we are talking about this A to C, that is you have got A, I am talking about A to C. Okay, so this is, what about the previous one? Let us consider this is the path of the projectile A to C. Okay. So the body travels from A to C. And let us consider the vertical one. Here the time taken for this traveling is t. We know, according to the fundamental laws of classical motion, S is equal to ut plus half at squared. Let us consider the displacement, and here u1, because at A it is u1, and into t plus, and let me put half into, in place of A. Now as I already mentioned, acceleration here it is under the influence of gravity, so you can put g into t squared. Got it? Let us consider this as equation number 1, and let us replace this s by y, that is the displacement towards y axis. And we know the initial velocity is 0, that at that position. Okay, so 0, u1 is equal to 0, so 0 into t means 0 plus half into, and then gt squared, therefore y is equal to half gt squared. Okay, half gt squared. Right? So this is the first equation, this is the second equation. Now let us talk about the horizontal velocity. So here horizontal velocity. u is constant here, because I already told you towards x, that is horizontal velocity, is always constant. That is not under the influence of acceleration due to gravity. And we know a fundamental formula, S is equal to V into T. S is equal to V into T. Okay. And here, that is, this is the horizontal axis. Let me say this is the horizontal displacement, as I had done the vertical displacement as y. Horizontal displacement will be x, is it not? So horizontal displacement x is equal to horizontal displacement. Take down. Okay, horizontal displacement, and that is nothing but s here. And what about v? In this case, this velocity is nothing but horizontal velocity, is it not? Okay, which is nothing but horizontal velocity. You can mention this as a v, u or ux, all are same, because it is maintained. So we can replace this equation. Instead of s, you can write x. Instead of v, you can put u, and t remains same. From this, t is equal to what? That is x by u. Am I right? So take down this equation. This is important one. This is equation number 3. Now we already have this y is equal to half gt squared. Okay, y is equal to, from equation 2, that is this one, y is equal to half gt squared, right? Y is equal to half gt squared. In that place, we can introduce half into g into, instead of t, you can put third equation, that is x by u, substituting t from 3. So half into, instead of t, you can put x by u whole squared. Do you understand this? So it can be written as y is equal to half into g x squared by u squared. Okay, and you know very well which are constant here. G is constant, correct, and u is also kept constant because horizontal velocity. Are you able to follow? So therefore g by u is constant. Got it? Therefore y is equal to this half, and let me split this constant separately. Half g by u into x squared. So when it is half, so here half g by u is equal to k, because constant, is it not? Therefore y is equal to what? Kx squared, which represents the parabola. Are you able to follow? And that is why the projectile path is parabola. So from this we have proved. Okay, so this is the equation of parabola. Parabola. So from this we have proved that the projectile path is parabola. Okay, therefore the projectile path is parabola. Do you understand? Got it? So the path of projectile. So how we have moved out? Vertical velocity Based on that, we were able to get to y is equal to half gt squared, starting from s is equal to ut plus half at squared. And horizontal velocity, where we are discussing about u constant and s is equal to vt, and we are replaced a t. Then we substitute in the previous equation, and finally being g u constant, and we have got k constant, so y is equal to kx squared. So that represents the parabola equation, and that is why the path of the projectile is parabola, hence proved. Okay, right. Next one. Now let us proceed with the resultant velocity. Point number 9. 10. Resultant velocity. So we have this projectile like this, and we started from A, and it has traveled, and it has fallen on the ground and hits here. So in between that is we have got, this is the horizontal velocity and this is the vertically downward velocity. Okay, so at C, so let me consider this C, and this is the velocity u, let us put, and let me consider, so if it is the case, let me put the C here. This is u2, downward velocity. It is u or ux, and this is the theta. Okay, this is the theta, because this is the angle of inclination, so this can be theta. Got it? So I put theta here. So this is the resultant velocity, or you will follow. The resultant velocity acts here. Now at an instant time, let me call t. Let the body at C, let the body be at C, that is here. Now at A, the initial velocity is equal to 0, is it not? That is u is equal to 0. Okay, initial downward velocity is equal to 0. Let me call it u1 is equal to initial velocity, that is equal to 0. At C, the horizontal velocity, how to represent the horizontal velocity? ux. So let me call it u. And at C, again, the vertical velocity, okay, so here it is u downward, so let me put y. Okay, that is nothing but u2 here. Now we know already v is equal to u plus at, according to the fundamental laws of classical motions. Okay, so here instead of v you can write u2, and instead of u initial velocity you can put u1, and plus instead of a you can put g, so t. You know already that is at initial velocity u1 is equal to 0, so put 0. Therefore u2 is equal to 0 plus gt, that is u2 is equal to gt. Okay, that is the vertical velocity is gt here. Now the resultant velocity at C. The resultant velocity at C. So that is given by, okay, according to the vectors, you know, that is, this is, you can apply the Pythagoras theorem. In fact, it is obtained from that only. So which is nothing but the square root of ux squared plus uy squared. Okay. And uy here is nothing but u2, which is nothing but gt. Is it not, according to the previous equation here? So we can substitute gt here. Therefore v is equal to the whole square root of ux is nothing but u, and instead of uy squared you can put the gt the whole square. Okay. So which is nothing but v is equal to the whole square root of u squared plus g squared t squared. Right. So this is the resultant velocity, and we want to find out the tan of angle of theta. So what is tan theta? Let me consider this. This is theta, and this one is ux. This is, you can put like this. Okay, so what about this? And this is a right angle. Okay, now this is u2 and this is u. Okay, now which is opposite side? u2 is opposite side. Adjacent side, u is adjacent side. What is tan theta? Opposite side by adjacent side. So can we write u2 by ux? Okay, so tan theta is nothing but u2 by ux. Do you understand this point? At C. So u2 is nothing but, here you can maintain as u2, and ux we have maintained this as u. So u2 is nothing but gt divided by u. Therefore tan theta is equal to how much? Gt by u, and theta is equal to tan inverse of gt by u. So we can find out the angle of the projectile also. So we are able to find out the resultant velocity of the projectile and the angle also. Okay, so we are able to find out the magnitude as well as the direction. So what is theta here? Theta is the angle of resultant velocity. Made with x-axis. So are you able to understand this? So what is the use of finding this resultant velocity? Along with the resultant velocity, we can find out the angle of projectile also. That is nothing but theta. Got it? Now let me talk about the time of flight. Eleventh point, time of flight. Let me consider once again. So we have thrown the body like this. This is A, and it has hit the ground, okay, at B, and from this is called the range. and this is O, and this is at right angle. Okay, right. So we know range is OB, is it not? Take down. And we know S is equal to Vt, displacement is equal to velocity into time, and here the range is the displacement, you can put R. Okay, this R is, S is nothing but the displacement, that is R, so you can replace by R, and instead of a velocity V you can bring the velocity U into, instead of T let me put time of flight TF. So this is TF. Okay. So R is equal to U into TF. Now at A, the initial velocity, take down, initial, what is the initial velocity at A? It is equal to 0, is it not? U1. Initial velocity, initial horizontal, vertical velocity is equal to 0. So the vertical distance is nothing but the height factor h, and that is nothing but the displacement along y-axis. Therefore, we know already S is equal to ut plus half at squared. And h is equal to, because S is nothing but h here. Okay, so we can introduce h as what? That is, which is nothing but sy also. H is sy, and h is here. U1 is a 0, and therefore h is equal to 0 plus, that is half, A becomes G. Okay, so you can put half G TF squared, correct? Because U1 is equal to 0 and A is equal to G. Now let us replace, instead of S let me write Sy, and instead of U you can put U1 TF, time of flight, and here half GTF square. Okay. So this Sy, so on one side we have, and we have this TF, time of flight, so from this we can have the time of flight. So TF squared, this is h is equal to this much, and TF squared, TF squared, okay, TF squared, that is time, is equal to 2h divided by G. So 2h divided by G, I have rearranged. Okay, and what about TF? TF is equal to the square root of 2h by G. Do you agree with me? So I have derived from this. Okay, so what is time of flight? Time of flight is nothing but the whole square root of 2h divided by G. And we can now find out R. So what is R here? R is equal to U into, this is not initial velocity, this is what velocity? Horizontal velocity. Okay, so U into, and what about this? TF. Instead of TF you can put this value into square root of 2h by g. So this is the equation for what? Finding out range. Okay. So what is range? Range is nothing but the product of u and the square root of 2h by g. And what is time of flight? It is given here separately. So both are very important. Okay. So we are able to find out the time of flight as well as range, both in this equation. Got it? Now let us proceed with the next type of projection, that is known as oblique projection. Take it up. So you can refer our previous diagram where I have given the take down oblique projection. Oblique projection. So this is the x-axis and this is y-axis. Now the projectile travel like this and falls on the ground, and this is the maximum distance. So this is h max. And it starts from O. As we already explained, ux is nothing but u cos theta, because this is u and this is the position C, where you have vertical velocity, horizontal velocity, and here also you have horizontal velocity, but the vertical velocity is 0 here. u3 is equal to 0 at A, and this is O. Let me call it as fallen here at B, and in between then you have got C and D. So this is the upward velocity and here it is the downward velocity. Let me call it u4, and this is u, of course ux, constant horizontal velocity, and this is u2. And what about this uy? What is uy? Which is nothing but u sin theta. So make sure all the labels are clear, and this makes an angle with the x-axis theta. What is theta? Angle of projection. And what is the range from the starting of the projectile till it falls and hits the ground? That is the distance between them, range. So what is ux? As we already discussed, ux is the horizontal component of the velocity. Horizontal component. Or projectile velocity u. and uy horizontal vertical component of u. As I already discussed, ux is always constant, uy is always variable, that is under the influence of what? Anyone? Gravitation, acceleration due to gravity. So it can be u1, u2, u3. At various stages you would have found out it is varying. In fact, at u3 it is 0, is it not? Actually this uy, decreases. Uy decreases, that is vertical velocity decreases upward when it travels. Initially there will be a high speed when we throw the object, but when it reaches the maximum height it almost reduces to 0. So decreases when it travels upward, and when it travels downward it increases. Okay, note down this point, because of acceleration due to gravity. Is it clear now? Now similar to that of projectile, okay, let us discuss the oblique projectile. So we have to start with, what is the point number? 11, and this is 12. Okay, now we are discussing about the path of what projectile? Oblique projectile. Let us consider similarly, t1 is the time taken by the projectile. Time taken by the projectile forward to reach the point C. That is from here to C. So horizontal distance is x. Horizontal distance travelled by the projectile is x. So s is equal to vt, that we know. So you can put, instead of x you can put x, instead of v you can put ux into t1. We know already ux is how much? U cos theta, is it not? We are given here. So we can put x is equal to u cos theta into t1. Okay. From this we can find out t1 is equal to how much? X by u cos theta. So t1 is equal to what? X by u cos theta. Okay. Now vertical distance. So what is the vertical distance, which is nothing but y, is it not? Vertical distance. So s is equal to ut plus half at squared. That is the basic formula. And let us replace y by s by y, because vertical displacement. Okay. instead of distance you can put displacement. So y is equal to, and initially it has got u1 velocity into t1 time, plus since it is ascending, so it is 1 by 2 into minus g. Previously we were determining the falling projectile. Now this is ascending projectile. Okay, it is climbing up. So it goes against the willingness of the acceleration due to gravity. So put minus g. So minus g into t1 squared, right? And we know already what is u1. u1 is nothing but u sine theta. So we can replace this u1. So y is equal to u sine theta into t1 plus, instead of plus you can put minus half g t1 square. Correct? Now we already know t1. What is t1? You please check it up. What is the value we have found out for t1? X by u cos theta. That's good. So we can replace this value here. So y is equal to u sine theta into x by u cos theta minus half into g into, we already know t1. What is t1? Time of flight. T1, time taken, x by u cos theta. Okay, x by u cos theta, the same thing we can substitute here. So x by u cos theta whole squared t1. Okay, now see, this is sin theta by cos theta is equal to tan theta, is it not? Cos theta. So you can replace by u tan theta. Okay, so we have now that is u can be cancelled, right? Therefore y is equal to what? X tan theta. Am I right? Next, minus 1 by 2 into g divided by gx squared divided by u squared cos squared theta. Okay, u squared cos squared theta. Now here this x tan theta represents, that is tan theta is nothing but a. Tan theta is a constant a. And what about these values? That is 1 by 2 g u and cos squared theta. These are all constant only. So 1 by 2 you can put minus 1 by 2 g divided by u squared cos squared theta. So this is equal to b. So in that case y is equal to, instead of tan theta you can put a. So ax plus, I have taken minus as a b. So the remaining is bx square. Okay. So this also represents the parabola. Okay. So the path of the projectile is parabola. Of the projectile. What projectile? Oblique projectile is parabola. Okay.